Hello and welcome to this Codefresh live event. This is a full guide to debugging Kubernetes pods with our special guest from RooCode. Zohar Aini is our speaker today, and he is a solutions manager at RooCode, where he helps people simplify their dev process so they can focus on code development. Take it away, Zohar.
Yeah, so thank you so much for the warm introduction. And everyone, I'm pleased to have you today with us for this webinar. I would like to go real quick of the agenda of today. So I'm going to discuss about difficulties when it comes to debugging Kubernetes applications. Then we'll go through both local and remote debugging approaches that are available today. And then we'll jump into a live demo where I will demonstrate how I am able to debug my application in production without writing more code, without redeploy, and without further Kubernetes configurations. And then we'll have time for questions, of course, from the audience. So as you can see here, this is a quote from Kubernetes Documentation site that discuss the difficulties when it comes to debugging Kubernetes applications. So as you can see in the underlined sentence, developing and debugging these services, Kubernetes services, on a remote Kubernetes cluster can be cumbersome. So I would like to begin with the local use case and explain how developers are handling today running and debugging Kubernetes applications on their own machine. So if you are more than 2 developers in the company, you might have an architecture that looks like this. So you have many microservices in different languages and third-party integrations that you use, all talking and dependent and depend on each other. And this architecture that is microservice-based is very hard to simulate on your own machine. So to tackle this issue, the first approach that I'm going to talk about today is an automation script that basically allows you to run all the microservices on your own machine. Usually this script is written by the lead developer or a DevOps person in your organization. And all the other developers will use it to simulate the architecture on their own computer. So in order to use the automation script, developers often change it in order to decide which one they would like to run and which one they would like to debug using their favorite IDE. So the one disadvantage that the automation script has is basically the developers will have to get very familiar with the automation script, and they will have to rapidly change it for their needs. The second option that developers have today is Hotel is an open source project. So some of you might be familiar with it. This is basically a visualization for the automation script, which allows you to see all the microservices that you run on your own computer and see each one's logs, and you can start and stop it. It's very nice. The UX around it is meaningful, although you still have the disadvantages, just like the script that one of your developers wrote for you. The third option, this is a very popular one, is Docker Compose. This is a tool for defining and running multi-container Docker applications. So this Docker Compose will have to be created and maintained, but it's not as bad as the automation script does in terms of the experience around modifying the Docker Compose. But one minor disadvantage is, the first one is basically if you have a more advanced Kubernetes configuration, it might be hard to replicate it using the Compose. In addition, it writes all the logs in one place, and it's very hard to understand the origin for each log message that you receive. I suppose that you probably ask yourself, why putting so much effort in running all those microservices and use different configurations when you have Kubernetes? And you have all the YAMLs in advance. So minikube basically is an official tool by CNCF, which allows you to easily spin up Kubernetes instances on your own machine using, of course, the Kubernetes configurations. Surprisingly enough, more often than not, your Kubernetes configurations will probably not work out of the box with minikube. For example, if you are missing an ingress controller, etc. So in addition, developers will have to be familiar with Kubernetes infrastructure and advanced configurations to decide which microservice they want to run and which one they want to handle by the minikube itself. So I think this is the reason why minikube is not so popular among developers, since it's very hard to change it while you are developing and choose which one you want to run locally and which one you want to run by the minikube itself. So those were 4 approaches for local debugging. Now I'm going to talk about remote debugging approaches. Remote debugging is a relatively new concept that I will elaborate now. And of course, our demo will demonstrate a remote debugging solution to troubleshoot and better understand how your code behaves while it's being hosted in a Kubernetes cluster. So the first 3 approaches I'm going to present is, the first one is the oldest trick in the book, is basically writing more logs and redeploy your code. But it has its overhead, since you probably have to, of course, write your code, redeploy, and wait for a long time. And you probably won't get all the data that you need in the first release. You will have to do it several times and adding more logs to better understand the root cause of the issue. And this is a very time-consuming process for developers today. The second option is attaching to a process. So attaching to a process requires a high-privileged user, since you basically have to share a process ID namespace between the debugger pod and the application pod itself. And you'll have to make sure that they can communicate with one another and configure ports accordingly. Yeah. The third approach is hybrid debugging, which allows you to basically isolate one of the services that you want to debug locally and make sure it's connected to the remote environment that you want to use. I'm sure that some of you heard about telepresence. So it's a very nice concept, but it's very hard to configure and use it. It has its learning curve, and developers will have to be familiar with Kubernetes concepts in order to use it. The fourth approach that I'm going to elaborate more today, and I'm going to show you the demo on the fourth approach, is adding more logs at runtime solutions. So you can enjoy basically the advantages that adding logs gives you, but you don't have to write more code or redeploy code for it. You can basically add those logs on the fly. So I think it's a good time to talk about RooCode, which basically implements the fourth approach. So RooCode, the solution basically uses a non-breaking breakpoint concept. Developers can choose from which lines they would like to collect data, just like setting up a breakpoint. Only RooCode's breakpoint do not break the application at any point. They collect the data and send it to the desired destination on the fly. In order to use RooCode, all you have to do is basically add an SDK to your application and set up several environment variables. It has nothing to do with Kubernetes itself in terms of the deployment and, of course, the user experience around it, which is another nice advantage that is important. RooCode supports Node.js, JVM-based languages, and Python. So I think it's most of you are probably want to see a live demo for how am I able to debug a live application. So prior to this webinar, I've created an application that is running on my Kubernetes cluster. It's actually up and live and running, and I can basically add more to-dos to it. I can navigate between them, and I can delete them. So for example, let's delete task number 1. Oh, Darren, did you see it? I have a bug in my code. I wanted to delete task 1, but it deleted all the others. It will be so hard for me to reproduce it on my local machine. So it's a good thing that I've integrated RooCode in advance. So if you have an issue, just like I had in the middle of a webinar with you guys, you probably want to go into this interface. So this is RooCode's interface. As I said before, I already integrated my service with RooCode. So as you can see here, RooCode is a web interface. It looks like an IDE. We want our developers to feel at home. But you cannot change the way your application behaves using this IDE. It's a read-only one. So on the left side, you can see the source view where you probably want to load the sources that you want to debug on the right branch. In the middle, you will see the actual file that you want to debug, and you will be able to set up breakpoints, again, and non-breaking ones to collect the data from a specific line. On the right side, you will see the breakpoints pane, which will show you all the different breakpoints that you've set and their current status in real time. And on the bottom of the screen, you will see the message pane where all the data that is being extracted by RooCode will be pipelined into here. So let's go ahead and simulate the bug that I just saw. And let's try to figure out what's the bug root cause and fix it, of course. So let's add a few more tasks. And let's go ahead and set up a breakpoint in the delete function that handles deleting the to-dos. So I'm pretty familiar with my code. I know that app.py implements all the CRUD operations in front of the tasks that within my application. So I will go to the delete function to do and set up a breakpoint in line 64. Perfect. So as you can see, I've added a breakpoint in this line, and these green indicators means that it's connected to my production environment. And if I'll delete one of the to-dos, I'll basically get some data that is relevant in this line. So let's assume that I want to delete task 1. And as you can see, all the other tasks has been removed, which is not the acceptable behavior that I want. So as you can see on the bottom of the screen, as promised, you can see an entire dump frame from this specific line. And I want to look into it and understand what's the root cause of the problem. So I have here to-dos, which is the to-dos from my database. And here I have another array that filters the one that I want to exclude. So I want to see what's the value for the to-dos and the new to-dos to better understand what my code does. So as I see, the to-dos has all the different data that I had before I deleted my task, which is good. And I want to take a look at the new to-dos. And as I can see here, I have only one task, which is not good. So I assume that I have a bug in line 62. So yeah, I think I can, I see the problem. Yeah, my filter is if the ID equals to the to-do ID and not different from the to-do ID. So yeah, I found a bug. It was pretty easy. It was a pretty easy bug. So as you can see, I used Ruko to set up a breakpoint and get live data from my up and running service in Kubernetes. I didn't have to do anything related to Kubernetes itself. I only accessed the web interface and set up a breakpoint, which is another advantage since developers are not so familiar with Kubernetes today. So let's go ahead and fix the bug because I don't like bugs. So I'll go to the delete function, which is here, and I'll change it to different. And I will redeploy my code. And I will push it to master. So I use Codefresh as my CI/CD product. So I have a pipeline which every time I push a new version of code to master is being triggered. It builds my application and deploy it to my Kubernetes cluster. So as you can see, it triggered immediately. So once my pipelining will be finished, I will be able to check if my bug was fixed. So meanwhile, I want to take a few keynotes, key takeouts, and explain what we've just saw. So you can use RooCode to debug basically by using a log line or a dump frame that you just saw with entire stack trace included. You don't have to write more code or redeploy. This is something you do only once. So once you've integrated the RooCode's SDK to your code and deployed it, you will be able to debug it from that moment. And of course, in a more advanced Kubernetes architectures and applications, you have many, many pods and many, many moving parts that is being hosted on your Kubernetes cluster. So RooCode will get the data from every pod that you've set a breakpoint for. So for example, if you have 5 pods, you will get data from all of them. And you can filter the data after you received it. So yeah, RooCode is built for highly distributed applications. by using, as I said before, Node.js, JVM-based languages, and Python. And this should ease your life when it comes to troubleshoot and understand how your code behaves while it's not on your own computer. So while my code is being deployed, I think we have 1 minute to talk about RooCode's new feature. We now support conditional breakpoints. So you can basically now set up conditions in a specific breakpoint and collect the data only if the specific condition is applied. So here you have the configuration for each breakpoint, where you can say, I want to collect data only if the to-do ID equals to a specific ID. In addition, you don't have to collect all the variables within this line. You can say, I want to collect only the new to-dos array, or the to-dos array, etc. So I think my new code is about to be deployed. Yeah, so what I'll do now is basically try to test if my bug was fixed. So let's add a couple of tasks and delete task number 2 and task number 1. And perfect. Seems like I've understood what the root cause of the bug was. By using RooCode, I got the entire dump frame just like I have in a local debugger, only occurs in remote. And then I fixed the bug, and now my customers are happy. So you can go into RooCode right now and sign up for a trial. We also offer a self-serve application. And if you'll sign up today from this webinar, we will send you swags right to your home, including these stickers to put on your computer. Developers love it, so feel free to sign up and we'll send it to you. Taryn?
Excellent, excellent. And we want to remind everyone that Codefresh has a free account for 120 builds a month. So you can sign up for that free account at codefresh.io or schedule a one-on-one with us if you want to hear more about our CI/CD platform also at Codefresh. Also check out all of our upcoming webinars at codefresh.io/events. So I want to make sure that we address all these questions now because we have a lot of wonderful questions. So I will start from the top. What is the overhead of the RooCode SDK? Does it make apps slower in production?
Yeah, so actually that's a great question. So RooCode consists of a concept called bytecode manipulation. We basically add logs to your code at runtime, which is equivalent perfectly as if you write log lines by yourself. So there is no overhead when it comes to using RooCode. There is a cost for the data that you want to extract. RooCode, in addition, implements CPU and memory threshold to avoid a hotspot breakpoint in your application. We will disable all the breakpoints immediately. But of course, you have the conditional breakpoints that I've just shown you to make sure that you don't get too many hits in a specific breakpoint.
Great, thank you, Zohar. And our next question, what happens if I work in a bank and my app has no internet access? Can I use RooCode in an air-gapped environment?
Yeah, so we have all kinds of layouts for RooCode. So I will be more than happy to share after this webinar the different architectures that we support. So we have a solution for it, and I will be happy to elaborate more privately. Yeah.
Sounds good. Thank you. So if you have, I can send out RooCode's contact information as well. So feel free to reach out to them directly. Mm-hmm. Okay. Will other languages be supported, such as Go and Ruby in the future?
Yeah. So that's another great question. We are currently developing for the Go and Ruby and .NET in addition. So we will support these frameworks, I think, in the upcoming month or two.
Awesome. And let's see, I have a question here also, how is RooCode integrated with Kubernetes?
Yeah, so basically since RooCode's implemented on the code level itself, you can basically debug with RooCode anywhere. We do not care where we are being executed. We basically, since you add our SDK and we have our own logic to get the breakpoints the developers set and implement the data collection capabilities, we just enjoy the fact that we can basically debug anywhere we want. So if you're using serverless, ECS, Kubernetes, even running on your own machine with Minikube, you can just use Ruko to debug it, since we're on the code level itself.
Thank you. And then I have a follow-up question. Any plan from the last question? Any plans for Erlang or Elixir?
Yeah, so we got also those requests. I think I can share the our plans for the frameworks that we support right after this webinar, but there is no current timeline for that.
All right, and the questions keep pouring in. They have all sorts of questions for you, Zohar. Okay, from Jacques. Hi, what is the impact of on-the-fly logging to the performance of the application itself?
Yeah, so basically RooCode has zero overhead. You do not have any overhead while using it on your performance, but you do pay for what you ask for. So if you wrote a log line by yourself, for example, logger.info and then string with parameters, or use RooCode to collect the same data that you want, you will pay the same price in terms of performance. But there is zero overhead if you're using RooCode.
All right, thank you. And how about, does the code really stop at the breakpoint, or does it get data around the breakpoint and move forward?
Great question. So RooCode implements non-breaking breakpoints. So this is, I think, one of the nicest things that allows you to debug in scale. We do not stop the application. You cannot step in or step out your process. We basically collect the data synchronically and send it asynchronically to allow the application to continue and perform as it should. So we do not stop the application, and we send the data that you care about right away.
Great. And also, can it be globally turned on and off depending on whether you're in debug mode or not?
So basically, you can use RooCode in a debug mode or without a debug mode, since we are basically an SDK to your code. So you can use both.
Great. And can RooCode be integrated with IntelliJ, IDEA, Ellipse, or Ellipse using plugins?
Yeah, so we are about to finish our IDE plugin for IntelliJ. It will be released in the upcoming weeks. So this is one of our most popular requests, which we're working on to allow developers to choose whether they want to debug using their IDE or RooCode's interface.
Great. And will RooCode collect dump frame in case of decorators in Python? I'm not sure if I read that correctly.
Yeah, exactly. Okay. No problem. Yeah, it will collect from a decorator as well.
Excellent. And does it support PHP?
Not yet. Again, I will be more than happy to share a descriptive timeline for each language that we support right after this webinar. But
excellent. And I'll make sure and send, I have all these questions with everyone's contact information. So I'll send all of these questions to Zohar as well. And if he wants to answer them directly, then he can do that also. So
yeah, sounds good.
Does this debugging work with minifeed JS code?
Yeah, so all you have to do is provide source maps to RooCode, and it will work perfectly for you.
Excellent. And I think we answered this one earlier, but if you'll reiterate in case anyone missed it, does it have a performance effect?
Yeah, so RooCode don't have any performance effect. In case, for example, you don't have any overhead by using RooCode. It has zero overhead if you are using it, since we practically adding more logs at runtime, which is equivalent in 100% to write this code on your own.
Great, thank you for restating that. If the application has n number of pods in the cluster, will RooCode be a sidecar in all of those pods?
So no, you basically, since you add this SDK to your application, RooCode will be loaded within each pod as part of the application code itself. So it will collect the data from everyone, and you don't have to do anything related to Kubernetes in terms of installation.
Great. And can you describe how RooCode compares or is better to Google Slack StackDriver, excuse me?
Yeah, so Google Slack StackDriver is another great option, but RooCode basically allows you to debug your code no matter which cloud provider you're using. We support Google Cloud, AWS, and every other cloud provider that you use. So that's, I think, the main difference between them.
Thank you. And let's see, can you use RooCode along with Istio?
Yes, no problem.
Excellent. As an admin of a cluster, can we check all the breakpoints?
Yeah, you have an admin panel that allows you to see all the breakpoints that you've set and configure them and put some limitations if you want on the data that is being collected, and disable all the breakpoints if you want. So you have a full admin control over your organization. We take the security very seriously, and we provide admins with lots of options and capabilities to make sure RooCode stands in your organizational policies.
Excellent. And went through your pricing details. It explains the pricing is based on the number of app instances and number of seats. Can you elaborate?
Yeah, so basically RooCode saves lots of time for developers. We basically save hours for our customers. So our pricing is per seat. It depends on the tier that you wanna pay for. The app instances is only for a fair use. So we just wanna make sure that you don't have thousands and thousands of instances compared to your legit usage. So basically we charge per seat, and we just don't want to see that you have too many instances that you're using. So basically it's not a problem in terms of the pricing, but the seats are the way we charge.
Excellent, thank you. So I still have a couple questions left, but I'm going to go ahead and launch our poll. Please let us know how we did today and if we met your expectations on the webinar. That this helps us for future webinars as well. So thank you for filling out that poll, and I'll continue with our last couple questions here. Let's see, can the data values that RooCode gets be anonymized in case we have PLL data?
Yeah, so RooCode supports blacklisting and whitelisting when it comes to the data that you extract. So you can specify, you can see it in our documentations, and really feel free to reach out to me directly and ask how to set it up. But you can redact specific variables that you know that you want to exclude by using a regular expression. And you can also use a whitelisting to basically specify which data you wanna collect, and all the other will be redacted.
Okay, and since RooCode is an SDK, which means it's consuming CPU RAM resources of the pods, can you explain why it would not impact performance?
Yeah, so RooCode basically is loaded into your code. While it's running, we're just listening and waiting for events to receive by the developer. Once we get the request, we basically perform a bytecode manipulation operation to add the specific line of code to your code. This operation itself, adding the capability at runtime, it has a minor overhead since we basically add the code on the fly. But this is like something that happened once or twice if a developer debugged their code, and this is like it's a very small impact compared to your entire application. So while we collect the data, there is no overhead. You just pay for what you ask. But the operation of adding the code itself, it has a very, very minor overhead. But it's nothing to worry about even in scale, since the developers themselves adding the breakpoints in human time. So it's something that will not harm your application at all. And RooCode has, again, a memory and CPU and rate limiting mechanisms to avoid a case where someone, by mistake, set up a breakpoint in a hotspot place in the application.
Excellent. So that was the last question that I see. If anyone has any remaining questions, please feel free to enter them. In the meantime, please remember to go to codefresh.io/events and check out our upcoming webinars. And I want to take this time to thank Zohar and Polly so much from Rookout for joining us today. And we will see you next time on Codefresh Live. Have a great day.
Thank you.
Bye-bye.
Bye-bye.